Welcome to this third video on machine learning and Minecraft. In the first video we set up the mineral environment so we could actually play Minecraft within kind of research Python environment, and the second video we used the OpenAI VPT, the video pre-training model, to annotate some videos that we found on the internet with what it wants to do in that situation. So this third episode we're going to essentially enhance what we did in the previous episode, which is to, instead of having a text output of what the model wants, we're going to have a video overlay. So this is much more interactive in that you can actually see what the model is trying to do, and then we're going to try and apply that to the output from my phone, which is running Android. So clearly there we've also got a version mismatch for Minecraft, in that the Java edition is what is being used to train the models, but my phone is running Bedrock, which has a slightly different appearance. So clearly I want to find out whether that's going to be a problem or not. Okay, I also want to point out that we've now got a repo called this DiamondJax repo, which basically has all of the description texts that you would otherwise find at the bottom of the video, and it also has some kind of explainers going on. So here we've got episode 1, episode 2, this episode 3 it explains what we're going to do, and has also some of the important steps for working with the phone. Okay, so let's get into it. So the previous episode has a collab which kind of ended up with us analysing the output of the VPT model when presented with a YouTube video. And we've got this YouTuber who's made a video about building a house, and we're just kind of seeing what it produces. When we played that through, it would give us some text output where it would tell us where it wants to point the camera, what it would do, like attacking and using at each of these stages. The problem with this is it's not very easy to relate like what is happening in the video to what is being seen. So what we're planning to do here is let's try and make a heads-up display so that we can actually see what's going on more readily. So if we're moving to a heads-up display, basically I've made some functions which will take a frame and then annotate them with the actions that the VPT model wants to do. Now part of that is a translation of the camera move into an actual kind of arrow on the display to tell us where it's trying to look. So to do that, I've needed to calibrate the camera moves to pixel positions. To do that calibration, what I've done is I've used the one in the intro video where we set up the mineral environment, and I then made some kind of calibration steps, and I've actually updated the original Intro Colab notebook with this. This action calibration steps allows us to essentially center our view and then move a piece either way, up and down. And so basically the output starts to look like here's the original view, here I've pulled up the inventory, and then basically I'm looking around up and down. It doesn't make so much sense when you see it listed here, but if I move over to the same thing in GIMP, you can see here is my inventory. I'll kind of crop this in. Here's my inventory with the 0,0 position, or the middle of the screen position. If I then move the camera up and down, basically I'm taking larger and larger steps to try, and that's up and down, and I can take steps side to side, so I can calibrate this in the pitch and the yaw positions. Okay, so having done that, if I go back to here, so that allows me to calibrate it, and if I then plot out what are the camera positions which the VPT output is telling me, and how does that correlate to the actual movement in pixels, I actually found a pretty linear relationship here. So the interesting thing is that the VPT can't output an exact number of degrees. It has it in buckets, so there are 11 buckets, which is 0 plus 5 buckets plus or minus either side. So what I did is I just calibrated to those bucket positions because those are the only things it could tell me, and I found this kind of neat linear relation which I can just use that going forward. This special 66.5 number is going to be the basis of how we're going to calibrate this. Okay, so that's how that step is done. Going back to the video overlay now, so this kind of explains, I've got a couple of kind of helper functions, but this cam to pix, this is explaining how a camera move relates to a pixel move to enable me to translate coordinates from one frame to another. I then essentially made my pretty print function into a video frame pretty print. So this enables me to annotate a frame with actions. And then as we go down, I've got something which will essentially read in the video capture from the video segment that we had before, and then it writes it out to a video writer. Now I played around with the OpenCV video writing, but that seemed to have like significant temperamental issues with getting it to work. So what I ended up doing is using ffmpeg, the Python version, which we used before, but this is now in an output sense. So I set up a piped version, so I can now write into the writer via a pipe, and this will then produce a nice video output. And I know for sure that ffmpeg can produce a video which I can use in the browser. Okay, so having done this, this will both print out when I apply it. So here I'm applying this to a video segment. When I do that, I can see that it's doing a tack, and this is the same output that it showed before. But if I go down to the bottom, basically here is my original YouTuber video, or whoever this YouTuber was, and you can see that it's, as we play it forwards, it will show all the different actions that it was trying to do at the time, as well as an arrow, which you can see in the middle, which is essentially pointing like where would it like to move the camera. Now, building a house isn't exactly what VPT is designed to do, and it's actually not one of the basalt tasks. Oh, sorry, it is one of the basalt tasks, but very unlikely to do it in this way. So what I wanted to do is now try it on my Android phone and see whether I can actually get it to annotate some video there. So going back to the repo, you've actually got some notes here about how I would go about recording my Android phone on my Linux machine. So I run Fedora Linux locally, which is maybe an unusual choice. I see from the Discord channel that an awful lot of people are using Windows. That's a pity, but there we go. I've got instructions for Fedora here. If people want to contribute like a whole bunch of Windows stuff, I'm happy to kind of add this to the repo, but I'm not going to be debugging any Windows issues. Basically, I've got a superior system and I'm going to use that. So basically, these instructions show how to set up the phone so that it's in developer mode so it can be recorded. Then with the computer, it just makes sure I can access this as a device using a USB cable. Then I install a screen copy tool, which has a Fedora repo. And then using that repo, I then essentially work out what is the size of the screen. So my screen is not the same resolution as the 640 by 360, which is what the input for the OpenAI VPT model needs. So basically I want to essentially resize it and crop it down so that it's going to be the right output, and also at 20 frames a second. So these instructions kind of explain the steps so that I could eventually just say, okay, record this with the right crop settings to a file name. Okay, so having done that, we can now move back to the Colab and we upload the file. So here we are back in Colab. My file is called file01 approach tree, because that's essentially what I did. This is a very small example, and the first thing I did is from a little ways away from a tree, I kind of meandered up to it. So I've picked out a little segment here. This is using one of the functions earlier in this notebook. This notebook you can download and use yourself. Basically, I've picked a 5-second segment, and you can see what I do is I kind of just wander up near the tree. Right? So I didn't want to like turn to the tree and head towards it, because I wanted to see what VPT will be trying to do. It will be trying to do the controls instead of me. I'm kind of sidling up to the tree here. Okay, so having done that, I will then run this create video with overlay function, which I defined above, and this outputs, here are the different things it wants to do. It wants to go forwards, it wants to do a bit of jumping, and then it wants to attack. Right? As soon as it gets close to the tree, it starts, well, from this text output, it looks like that's what it's trying to do. Let's just have a look and see what the output from the heads-up display looks like. So what we've got here is in the top left corner, we've got the frame number. So this starts at 01, but basically it's looking at the first frame and it's then overlaying what VPT thinks it wants to do. So we've also got in the middle an arrow, and this is kind of like where the VPT wants to move the camera to. So as we play this through, you'll also see it flashing up, forward, sprint, jump, all this kind of thing. So these are the buttons that the VPT is trying to press. You'll also notice kind of in the background that it's still got some controls here. This is bedrock controls on my phone. The toolbar is in a slightly different position from what you'd see in Java. And also you've got a press mark here. So this circle is kind of where my finger is, as I move around and okay. So one interesting thing here is as it jumps up, and then as it's near the tree, you can see it's continually trying to get the tree to be centered. Yeah, you can see the arrow kind of flashing that it wants the tree in the right position. So this is kind of interesting idea that once it sees a tree, it kind of really wants to approach it, which you can believe because in the early game, if you've got nothing in your inventory, you probably want to hit a tree. So now let's go on to a later part of the demo, or my little 20-second video file I recorded. Here what I do is I'm beside the tree now, and I'm going to look around up and down and then look at the tree. Right? So you'll see if I just play this through, here I'm looking around but not, and now I look back at the tree. Okay. So what I was trying to do is test here, like did VPT want to move my point of view onto the tree, and what happens when it got to the tree? Because clearly it's gonna, I would hope, it's gonna try and attack the tree and then go and collect the logs. So we can just, since everything is now a function, we can just run these functions. You can see that it's trying to move forwards, it's trying to move the camera, it's doing a bunch of attacking. This is in the later part. So okay. In the earlier part, I think it's moving around more violently in frustration because I was only kind of near the tree. So here we go again. Let's have a look. You can see that here it's the camera's trying to make more violent movements. I can actually go backwards and forwards, so you can see that the actual camera's trying to get hold of the tree like this. But as I gradually point myself towards the tree like it wants, now we're moving on to the tree, it's trying to go forwards, it's trying to attack a lot, right? So basically it's happy with the camera position, it's now wanting to hit the tree. And it also seems to want to go forwards, so it's right beside the tree once the logs drop. So this is really proof that having this heads-up display is a super useful thing to have. And of course the code for all of this is in the Colab notebook, and as I mentioned, the repo now has links to all of this and also much better description text. And if you want to raise issues, then please do so on the repo or leave a comment. Particularly, I think if you leave comments, then the YouTube algorithm will like it. But if you want to make updates to the code, leave a comment, say you've made an issue, that would be even better. Then we can get some kind of synergy going. If you like this video also, why not mention it on the Discord channel? I encourage you to go to that. Lots of people talking about how to set these things up. And hopefully we can all, make this stuff better together. Thank you very much for watching. I guess I'll have some future videos on, maybe a bit of JAX for the machine learning side. But I also noticed that now there are some Basalt challenge demo reels to look at. And so I might go through those to kind of explain what techniques are being used from kind of like a Minecraft and a machine learning perspective. All right, see you next time.